This conference will now be recorded.
So in the last lecture, we had started the hydrograph. This is very, very important in the hydrology, right? This hydrograph is very important. So hydrograph is what just when, suppose this is our catchment, right? And rainfall occurs. So what happens? This is suppose our main stream. So whatever the rainfall occurs through main stream or some sub-stream, water comes in this stream, and through this stream water comes into the main stream, and then it at this outlet we measure the discharge, right? We measure the discharge at this time, like for example at in the morning, suppose at 8 a.m., right? It was 0. Then suppose after that 9 a.m., then 10 a.m., then 11 a.m. Rainfall started, and when rainfall started, so here discharge is collected. For example, this is say 50 meter cube per second. Then say again 100 meter cube, then 150 meter cube, and likewise, right? So when we collect this discharge rate, then we draw in the graph like this one. So on x-axis we take the time, right? And on y-axis we take the q, that is the discharge, right? So here, for example, what I told you that when we collect this discharge, we draw on y and x axis, and we get one graph. So you can see this graph. So this graph is just, this is called as the hydrograph, right? This is called as hydrograph. So here the hydrograph is again having the different components. So these components are, you can see here. Mm, So you can see when the this discharge is collected, started, and it reaches up to highest level, and then it goes again down, right? So these terms, this limb, this is we can say this is called as uh, the rising limb, or we can say the, and this limb we can say that is the falling limb, right? Here we can see this. These components are here. So we have some rising limb, this one, and falling limb, this one. Then one thing I will do is more important than, see here. I have taken here because of I have to explain the things. See here, this term and the rainfall. See, this discharge is collected. This is our catchment, right? Discharge is started, and we are collecting at this point, right? So when say this is the time, and this is the DQ. At time 0, discharge was 0, then after 1 hour, then 2 hour, 3 hour, 4 hour, 5 hour, 6 hour, likewise. So whenever the rainfall occurred, suppose this rainfall occurred for 1 hour. So whatever the rainfall is occurred here, this discharge will be collected. And this rainfall water, this water will come in the stream very slowly, right? Even the rainfall is occurred only for 1 hour, but the discharge will be collected maybe for up to 6 hour or 7 hour, right? So suppose after 1 hour, the discharge will be say 50 meter cube per second. Then say this is 100, then 150, then 200, or we can say again it is suppose it is we can say it is reducing. So again this is say 100, then 50, then 0 likewise, or 40 likewise. So when we will draw the graph, so what we will do on x-axis, we will take the time, right? On y-axis, we will take the discharge rate. So at time 0, or here we can say this is discharge is say 10, 20, or not 10, 20, we can say so this is 30, this is 60, then 90, then 120, likewise 150, right? So here the time is taken, say 1 hour, then 2, then 3, then 4, then 5, then 6, right? Now at 0 time, the discharge is 0, right? That after 1 hour, the discharge is say 50, 50 is somewhere here, somewhere here. Then after 2 hour, it will be say 100, 100 means somewhere here, right? Then after 3 hour, it will be reached to say 150, somewhere here. Then again after 4th hour, it is reducing, means it is again it has come around 100. So here it will be say this is actually this is 100. Okay, now here this is 100, then 50 somewhere here, then 40 likewise. When we will draw the graph, when we will join this, right, we will call it as a hydrograph, right? Now one thing is clear, how the hydrograph is drawn, how it has come, right? Now here the time when it is started and when it is ending or it is becoming constant, that is called as the base time actually, right? Base time, base time means when it is started hydrograph and when it is ending. Now again I will see. This is our hydrograph, right? Now you will see that when it is started somewhere here from here and when it is ending, it is said that this is the base time, or what we will say base period, right? And it is denoted by T suffix B, base period or base time, right? Is it clear what I'm saying, Salim, Zaid? Okay, now this is the peak point, right? This is called as crest or peak point. Means this is the highest discharge actually. We can say it is denoted by QP or C, peak discharge, or that is called as peak discharge. Means this is the highest discharge on that after the rainfall at this outlet, which is the, so we in this case we say this is a 50 meter cube, 150 meter cube per second. Like in our case, we have taken these discharges, right? In our case, this 150 is maximum, right? So this is the highest peak. So QP in our case is say 150. That is the highest discharge rate. So it is started from this point up to here. So this will be on x-axis. This is the time, right? So this time will be called as TPK. That is, we can say that is the time for the peak discharge, right? We will say it as a peak discharge. We can say that is the time taken by the peak discharge, right? So here you will see that this time is given here. Hmm. Is it given here? Here not given, but here it may be given, right? So if you will see that, see here you will see they have given as a TP, or sometimes sometimes it is denoted by TPK, right? The time required to for the peak discharge, right? Now next is, this is rising limb, this is recession limb, right? And what I want to tell you now, here you will see that in this, not in this one, not in this graph, and the here. So here you will see that lagging time means when it is, we can say from here, when up to when it is just at the reach of reducing, right? This is the lag duration. This is called as the lag time. And time of concentration means I have already explained this. If suppose our catchment is this one, this is the last particle, to travel to this last particle up to the outlet, what time will be required? That is called as time of concentration. It is generally denoted by T suffix C. See why I am telling you this. This is very important. Once you should know that everything, because in our hydrology, this hydrograph is very important, right? Now you will see what I want to tell you, that you will see that this is our x-axis and this is our y-axis, right? So this graph actually is not started from zero. It is started from somewhere here, right? So this is zero and this is some value, maybe anything, a 1, 2, 3, whatever value. Generally, if you will see that this is the graph, if this is the zero and this is the last, so we make like this. But here you will see that there is something value. What is that? This is called as the base flow. Base flow, right? What is this base flow? Now again I have to come to our starting part which we had discussed. See here, we know that this is our surface and the rainfall occurs. So what happens once this porous porous of earth surface pores of earth surface become filled with water, right? Filled with water, then what happens? After certain period of time, whatever the rainfall is coming, it does not come into the soil, it directly flows, right? It directly flows. So we say that this is the runoff. So runoff occurs because of some excess rainfall, means some excess rainfall. So this runoff occurs because of some excess rainfall. Excess rainfall means directly the rainfall which comes here, it does not go inside, right? It flows directly. It flows directly here. So due to this excess rainfall, due to this excess rainfall, runoff occurs, right? And we have already seen that this runoff is called as the direct runoff, right? This runoff is called as direct runoff, and we have seen that the direct runoff, this one is equal to the surface runoff plus this is prompt inter prompt interface. We have seen already earlier this thing. Now, what I'm going to tell you the base flow and why this base flow is there. So this is one of the direct runoff, and then another thing we had seen that the base flow, and we know that what was the base flow if it is our Earth surface, right? Ground surface. So when the rainfall occurs, some quantity of water comes below the surface and it reaches to this water table, right? This is a water. This is water table. So whatever this water is coming, it meets to the water table, and this water table meets to the river. Suppose this is the river. Here it is the supposed river. So this water meets to this river. Now you will see that even if there is no rainfall, and if we have some river, the river is continuously flowing 365 days. Why? Because whatever the groundwater is coming, whatever this groundwater is nothing but our base flow, right? So this base flow is already present in the river. Because of this base flow, water is already present in the river. Then after what happens? Then rainfall occurs. So this base flow comes in the river after the rainfall, around maybe after 6 months or maybe after 1 year. This base flow meets to the river, right? And it continuously fill the water into the river. So because of this base flow, there is already some water in the river, right? And then the direct runoff also play important role to fill this river, right? To fill this river. So this quantity of water is because of direct runoff, and this quantity of water, this blue color, is because of base flow, right? So when anybody will measure the discharge here by discharge means Q. This when anybody will see this Q, obviously this base flow is already present here, right? So that's why now you will see that. That's why you will see that when they are preparing the hydrograph, when they are preparing the hydrograph, there is some discharge is already there, right? There is some discharge is already quantities there, and they after that they have started and they have drawn. So this quantity of water which is already present, and because of that water, the river is continuously flowing. This is called as base flow. Is this okay? Base flow is okay, Salim, right? So that's why this quantity of water is called as the base flow, right? Now, if you will see that on y-axis, when you will see any hydrograph, there will be like this type of box will be there. So this type of box means what? This portion, this horizontal portion says that generally you will see that they have written as a D hour. D hour means that whatever this hydrograph is the result of rainfall, right? This hydrograph is the result of rainfall. right? So this rainfall may be of 1 hour, maybe of 2 hour, 3 hour, 4 hour. So instead of saying this 1 to 3 hour, generally it is said that the D hour rainfall. So that's why this D hour is written here on a horizontal portion, and this vertical portion represents the excess rainfall. And just I told you what is excess rainfall. Excess rainfall is the rainfall because of which the runoff occurs, right? So you will see that this portion is given, and this is called as the excess rainfall. Now base flow is clear to you, and this base flow and this hydrograph is because of direct runoff, right? Direct runoff. So this direct runoff and base flow is nothing but we can say they are playing they are playing important role for making this hydrograph, right? For making this hydrograph. So here, if I want to say that, if I will say that the total runoff is equal to, I can say that the total runoff is equal to direct runoff, direct runoff plus base flow, right? So this total runoff is what? Direct runoff plus base flow. And this hydrograph is, we can say this hydrograph because of the total runoff. So I will say that this hydrograph is flood hydrograph. So whatever the hydrograph will be prepared because of this total runoff, that hydrograph will be called as the flood hydrograph. Now you will see that our this hydrograph means this hydrograph is prepared with base flow also and with direct runoff hydrograph. So we can say that this hydrograph is the hydrograph which will represent the flood hydrograph, right? Is this okay? My point is okay. My point is okay. See, this hydrograph is prepared because of base flow or base flow and direct runoff. So that's why this and direct runoff plus base flow is nothing but total runoff. And this hydrograph is generated because of the total runoff. That's why this will be called as the flood hydrograph, right? So the hydrograph which will represent the total runoff will be called as flood hydrograph. So here I can write the flood hydrograph is in result of total runoff, is in result of total runoff. Now, if I will see, if I will deduct this base flow, if I will deduct, if I will not I will not write this, I will not draw this base flow diagram. If I will directly draw only this hydrograph from 0 to here like this, if I will draw the hydrograph like this, from here it is 0, and on x-axis here it is the time. So here this is the time, on y-axis is the discharge in meter cube per second, right? So here it is started from 0. So this hydrograph is, what is that? This hydrograph is because of only direct runoff. So I will say that the hydrograph which will represent the direct runoff, that will be called as the direct runoff hydrograph. So I will say that direct runoff hydrograph is a result of direct runoff only. Is a result of direct runoff means there is no base flow, right? Is this point is clear? So there are the two types of hydrographs we can say, right? If we will say that the first hydrograph is this one, and the second hydrograph is this one, right? So this is what this is my direct runoff hydrograph. In short, we write this like direct runoff hydrograph, and here this runoff hydrograph, this hydrograph will be called as flood hydrograph because of total runoff. This hydrograph will be called as flood hydrograph. Now, is this clear? Is this clear to you? This what is the difference between these two hydrograph? Here it is Q, here it is Q, meter cube per second. Here it is meter cube per second. I hope it is clear to you. Now, so it means that whenever we have to draw the direct runoff hydrograph, then what we will do? We will do one thing from flood hydrograph. If we will deduct the base flow minus base flow, so see, if this base flow will be deducted, this is what, this is our base flow. If this base flow will be, if this base flow will be deducted from flood hydrograph, we can get the direct runoff hydrograph, right? Direct runoff hydrograph. Now, I think it is clear to you. This base time, lag time, time of concentration, time to peak is clear to you. Here this portion is called as rising limb, right? This is rising limb means this portion, right? If you will see from here to here, this is what this is called as falling limb. This is called as crest, or it is generally denoted by QP, means where the discharge is maximum. And this is base flow. Base flow is clear. Now, we had seen up to here in the last chapter. Now, here you will see that there is a one method to separate the base flow, right? See, what is this n? This n is what number of days, and this is calculated through this formula 0.83 into a raised to the power 0.2, and a is what catchment area. So once we know the n, so this n is estimated from the peak, whatever the n value will come here, somewhere, suppose it is coming here, right? And we know that this hydrograph is started from this point, right? When we will directly join this line to this point, then we can separate the base flow, right? That is one of the method to separate the base flow. Directly, this green line, you can see this green line is directly joined to this point, right? Another method, this is one of the method to find out the base flow. Then another method is, we know this is the crest point or highest point. If we will draw vertical line, it will come somewhere here, right? And here the discharge is started. First, this is joined, and from here to where the n is coming, this value is coming. This is the another method to separate this base flow. This is what, this is our base flow, right? Base flow. Base flow means this is the quantity of water or discharge which is contributed by the river, right? Contributed by the contributed by the groundwater, contributed by groundwater, contributed by groundwater to the river, to the river. Am I right? This point is clear to you? Is this clear to you? This point is clear? So this quantity of water, there are the methods to separate this quantity of base flow water. Now another method is directly where this graph is started and where it is coming around straight, or we can say this constant is when it is reducing from this point. If you will see, this point is exactly horizontal, we can just directly join this, so that again we can separate the base flow. This is the another method. So there are the three times. First, you join by this green line. And what is this green line, where it is coming, how it is n is coming, we have calculated from here. So this is one of the method. This is another method. The method is this one, and third method is this one, right? So this is just a method of separation of base flow. Now, the same thing which I talked to you, the direct runoff hydrograph and the hydrograph, or we can say this is flood hydrograph. This is our flood hydrograph, right? Flood hydrograph, and this one is our direct runoff hydrograph. The difference is what? The difference is this base flow. This base flow is actually here, they have not, this should come actually somewhere here than this. Anyway, the point is clear to you, right? Now within that, I want to explain some more thing. Uh, Here, just I will stop here and I will explain some more thing to you. See, one thing you should remember, that this TB is what we have already seen this. If it is our hydrograph, right? It is started from here. So what, from here to here, this is what? This is the base period, and it is denoted by TB, right? Here, this is what? This is our TP or TPK. That is the time to peak, right? This is QP. So always remember that this, and here we have seen this one box is there, and here D hour. D hour means what? We have seen for how many hours the rainfall occurred, right? How many hours the rainfall occurred. Suppose that may be 1, 2, 3, 4, maybe etc. So instead of saying this 1, 2, 3, we say generally D hour rainfall, right? And here it is excess, this vertical portion, this one, right? This vertical portion is called as excess rainfall. Now, what I want to say you, always remember that this TB will be always greater than the D hour. D hour means what? Suppose this is our catchment area and the rainfall occurred here. So this rainfall occurred is for say 1 hour. So this 1 hour is what? Our D hour, right? D hour means what, up to what duration our rainfall occurred. And after the rainfall, you will know that this will come first into the small rivers and then it will come into the main stream. And after the certain period of time, it will come at the outlet, right? So the time which is required from this starting to end is TB, right? So always remember that this, if this rainfall occurred only for 1 hour, but the time will require more time will require to travel this rainfall water at outlet. That is what we can say, that is TB. So always remember that this TB will be more than the our rainfall hour. Is this okay? My point is clear. This point is clear to you. Whatever the rainfall is occurred, say for 1 hour, that rainfall occurred for 1 hour. But after the rainfall, the whole water is collected for say 7 hour or 6 hours. So that hour is what? That is TB hour. So that TB will be always more than the our D hour. Means that is our rainfall duration. This is our rainfall duration, right? And this is what? This is the duration from where the hydrograph is started and it is ending, right? So this is our TB. This TB is always greater than our D hour, right? Now, just I will give you one small example, and then it will be more clear to you. See, just I say that ordinate. Ordinate means what? Ordinate means say this is suppose time is given and discharge Q is given in meter cube per second. Time is given say 1 hour, then 2 hour, then 3 hour, then 4, then 5, and the data is given like say this is a 25, 27, 29, 28.5 for example. I am telling you this is 26. So all these are called as ordinates of hydrograph, right? These are what? These are the ordinates of hydrograph. Ordinates of hydrograph means whatever the numbers will come on x-axis and y-axis, these are our ordinates, right? So here the order, just what is the question? Question is saying that the ordinates of 2-hour flood hydrograph of 5 centimeter excess rainfall, excess uh, just wait on 1 minute. Okay. So this is of hydrograph of 5 centimeter excess rainfall depth given. Now it is saying that find the direct runoff hydrograph if base base flow is equal to 20 meter cube per second. So what is saying? The ordinates of 2-hour flood hydrograph of 5 centimeter excess rainfall depth is given. Find the direct hour runoff hydrograph if the base flow is 20 meter cube per second. And the ordinates they have given that the time is given and discharge that Q is given, right? This time, what I told you, the time is say after 1 hour, then 2 hour. Time is in hour, right? And discharge is in meter cube per second. 3, then 4, then 5, then 6. And suppose this is given as 25, 27, 29, 28.5. This is 26. This is given, and we have to find the, see what the question is saying. The question is saying that flood hydrograph is there, just you prepare the direct runoff hydrograph, right? So first of all, what I will do, I will take this x-axis and y-axis, and I will mm, just wait. Huh? So here I have taken x-axis, I have taken y-axis, right? Now, if you will see that what they have given as a time 1 hour, 2, 3, 4, 5, 6 hour, and they have given the discharge, that is Q. We know that on y-axis we draw the discharge. We will show the discharge, and on x-axis we will show the time. So time is say 1 hour. So I say that this is 0, then the 1, then 2, then 3, 4, then 5, then 6, whatever. See, this is 0, this is 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour, right? And here just what is the discharge is given from 25 to 29 is the maximum. So, and what is given? What is saying that the base flow is 20 meter cube per second. So here just they are saying that the base flow is 20 meter cube per second. So here I say that say this is 20 meter cube per second, and see 20 meter cube per second means that this is my base flow, right? This is what? This is my base flow. So everywhere it is like horizontal, it will be like horizontal. This is my base flow. Now, what he is saying that after 1 hour, what was the discharge? 25 meter cube. So here I take just say this is 20. No? Now here I take say this is 25, this is 30, this is a 35, like whatever. So at 1 hour, what was the discharge? 25. So here I will write here somewhere here. Then after 2 hours, what is the discharge? That is 27. 27 means somewhere here I will write. Then after 3 hours, it is say 29, somewhere here, right? And after 4 hours, it is 28.5, something somewhere here. And this after 5 hours, this is 26 means somewhere here. See, when I will join this, just it is somewhere here, right? 26. When I will join this, I will get the, what I will get? I will get, this is 2 hour flood hydrograph. Is this clear up to here? It is clear to you? Salim, Zayed, up to here it is clear? Just I want to clear what is flood hydrograph and what is hydrograph only, and how we are making this Is this clear? See, okay. Now, see here, what in the problem if it is said that 20 meter cube per second is the 20 meter cube per second is the base flow. Means what I said here, this is 20 meter cube per second is base flow. Right. Now, if I will deduct from 25 to 20, see this one. See, if I will deduct from 25 minus 20, I will get some ordinate that is 5. Here 27 minus 20, 29 minus 20, 28.5 minus 20 and 26 minus 20. I will get something. This is will be 7, this will be 5, this will be 9, this will be 8.5, and this one will be what? This one will be 6, right? So if I will not draw this, if I will not draw this, so if I will draw only the upper portion, then that will be what? That will be what? That will be my direct runoff hydrograph. See here, I will start from 0, then 1, 2, 3, 4, 5. And here, see, I have deducted that base flow. So here, add 1 hour, this is 2 hour, this is 3, this is 4, this is 5. See, now see here, add this 1 hour. What is my this direct runoff hydrograph ordinate? That is 5. So here, just I will take this a 5, 10, likewise, right? Or I can say this is 2, 4, 6, then 8, and maybe say 10. So at 1 hour, my excess runoff hydrograph ordinate, direct runoff hydrograph ordinate is 5. At after 2 hour, it is 7. So somewhere it will come here. Then after 3 hour, it is 9, somewhere here. After 4 hour, it is 8.5, somewhere here, not here. And then after 5 hour, it is 6, right? Somewhere here. So if I will join this from 0 to this 5, then this is what? This is 7, this is 9, ninth ordinate, this is 8.5, this is 6. Now this graph which I prepared, it will be called as direct runoff hydrograph. This hydrograph will be called as flood hydrograph. Is this okay? Is this okay? So simply what I did, if I deducted the base flow, this base flow I deducted and I prepared the hydrograph, then that is what? That is my flood hydrograph. So you will see the peak of this flood hydrograph is how much? Peak of flood hydrograph, that QP is 29 because this is the highest one. See, this value is highest one in this row, right? And in direct runoff hydrograph ordinates, these are what? These are what? These are nothing but the ordinates of direct runoff hydrograph. And these are what? Also time, huh? Okay. So these are what? These are the ordinates of flood hydrograph and time also, right? And here the plus time. So time means 1 hour, 2 hour, 3 hours. So these are what? These are our ordinates. I hope that this is clear to you now. Second, one thing is that, see, flood hydrograph ordinate, that QP is 29 and direct runoff hydrograph QP is how much? That is only 9. If I will take the difference of these two, I will get what? That is 20. So sometimes it may be asked that find out, sorry, 29 minus 9, 20, right? So that is what? That is the direct runoff hydrograph sorry, this one is just just wait. This one, if this is the base flow is how much? Base flow is 20. This is not. This is base flow. So if 29 minus 20, I will deduct it. So what I will get? I will get 9. And this 9 is what? This 9 is the QP of DRH. I think it is simple. Is this okay? So simply you remember that if we have the hydrograph and if hydrograph is like this and there is some base flow and plus this so when these two things will be there, then we will say this is flood hydrograph, right? Flood hydrograph. And when there is only no base flow, direct hydrograph is there, so we can say direct runoff hydrograph, right? Now what I said you, because of this is this hydrograph is generated because of 2 hour flood hydrograph, because this 2 hour is given in our question, right? So that's why, see, in the question it is given that 2 hour flood hydrograph. So this 2 hour is what? This is our D hour. So that's why we will say that this hydrograph, this 2 hour is what? This 2 hour is flood hydrograph, that is our D hour. Is this clear to you? Basically hydrograph is clear, and what is direct runoff hydrograph is clear. Means when flood hydrograph is there and base flow is there, so when we will minus this base flow from flood hydrograph, then we will get the direct runoff hydrograph, right? Now what is unit hydrograph? Just last portion, only 5 minutes remaining. I will complete this unit hydrograph. What is unit hydrograph? And then after we will start the numerical on it. So some 1 2 numerical is there. We will solve in the next week. Just I will explain what is unit hydrograph. See, see what is unit hydrograph? See, we have the direct our run. We have this direct run of hydrograph, right? We have direct run of hydrograph, right? And this direct run of hydrograph, here it is given for which hour, right? Suppose if it is given 2 hour, right? And here this is what? This is excess rainfall. This excess rainfall may be 1 centimeter rainfall, 2 3 centimeter rainfall, 4 centimeter rainfall, maybe 5 centimeter rainfall, maybe it may be of any depth of rainfall, right? So on x-axis we have a time, on y-axis we have a q, that is in meter cube per second. So what is unit hydrograph? So unit hydrograph is, always remember that the hydrograph which will be generated because of only 1 centimeter effective rainfall, right? For example, the rainfall in the rain gauge is collected only 1 centimeter. So we measured this and this is a 1 centimeter rainfall. And through this 1 centimeter rainfall in the catchment, the discharge is collected at this outlet point, right? So, for example, the discharge is collected at the outlet point, say at time, and this is Q, that is meter cube per second. Time is in hour, right? See, time is say after 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, and the discharge is maybe anything, say 10 meter cube, 20, then 30, then 40, then again 30, for example. This is 20 and then 10 likewise. So all this discharge is collected at this outlet, and this discharge is only because of 1 centimeter rainfall only. So because of this 1 centimeter rainfall, this these ordinates are collected, right? These ordinates are collected. So what we will do, we will draw the graph. So how we will draw graph? We will take on x-axis and y-axis. We will take the time on y-axis. We will take the q, right? And just we will try to draw. Suppose this is 1 hour, 0 hour, 1 hour, then 2 hour, then 3 hour, then 4 hour. So again, one graph will be generated. So this graph is because of only 1 centimeter rainfall, right? This graph is because of 1 centimeter rainfall. So that graph will be called as unit hydrograph. See, this is also the unit hydrograph will also be called as the direct runoff hydrograph. But all direct runoff hydrograph will not be a unit hydrograph, but we can say unit hydrograph is the direct runoff hydrograph because of this hydrograph which we have here generated. This is because of only 1 centimeter rainfall. Is this okay? Unit hydrograph is okay? Unit hydrograph is okay? Is this okay? Unit hydrograph is okay? Okay. So see, rainfall may be 3 centimeter, maybe 4 centimeter, maybe 5 centimeter, but and because of these centimeter rainfall, we will draw the hydrograph. That graph will be called as the, we can say, direct runoff hydrograph. But when we will draw only for 1 centimeter rainfall, then that graph will be called as the unit hydrograph. Now we will see in the next class how to derive the unit hydrograph from the flood hydrograph, right? Is there any doubt right now, up to any doubt? Okay, so here I stop, and most probably we will try to take the quiz in the coming Wednesday, right? In the Moodle, or maybe we will take as a regular paper by likewise. So be ready with next week Wednesday quiz, maybe there quiz 3, and total we will take almost 4 quiz, and best of 4 we will take 3 quizzes marks, best of 4 3 quizzes and 2 assignments. So okay, very good, very good. So here I stop. If you have any doubt, you can